Here's a full FRQ on the topic of fluids. This one is an experimental design question. The question says there's a tank of water with some liquid in it, and students are going to do an experiment. They have access to more liquid, a meter stick, and a pressure sensor. And very important in this question, it says they do not have access to a scale. Parts A and B are both going to be about thinking about how to design an experiment. And they want us to calculate the density of the liquid with the things they've given to us. So in part A, we talk about how to design an experiment that would help us to calculate the density of the liquid. Before I answer the question directly, I want to talk about the idea of this. It's always helpful to have an equation in mind when we're answering parts A and B. We're actually not going to refer to that equation directly, but we need to understand what equation we're talking about. Now, to measure the density, we might say we're going to use the density formula, mass divided by volume. But that would be wrong because the question says we don't have access to a scale. We can't measure the mass. Instead, we're going to think about the pressure formula, pressure equals rho GH. So we can measure the pressure and the height, and we can measure gravity as well. So we're going to use this formula to think about calculating for rho. Now, if we just know exactly what the pressure is and height, we can calculate rho directly. However, in experiments, what we like to think about is a linear graph. What I can do is imagine a graph where I plot h on the x-axis and p for pressure on the y-axis. And it's going to be a linear graph. In this case, I can think about y equals mx plus b. So the h is like the x, and these two terms together are going to be like the slope. And this one here is like the p for pressure. This is going to help me answer both parts A and B, but I wanted you to see this before I write down what the answer is for part A. So part A1 says we need to indicate what we would measure to calculate rho. And the answer is we need to measure the height and the pressure. When we write an answer to indicate, all you have to do is say the correct answer. You don't need any of the correct logic behind it, but you need to say, I would measure the pressure and the height. For A2, we need to describe an experimental method for doing that. For describing this, I like to think about having a student that doesn't know very much about physics and instructions that would help them to be able to do it. So we need to begin by saying we measure the pressure and measure the height. So you literally say something like, I would take the meter stick, put it on the side of the tank of water, and measure the height. I would take the pressure sensor and measure the pressure. So you need to say something like that. You also need to talk about reducing experimental uncertainty. And the way we do that is by taking multiple points of data. The goal in an experiment is to get multiple points of data like this. So each height will give a different pressure. And after we get the data, we're going to draw a line of best fit. The way we've said it so far is we only are going to use one height of liquid and only get one pressure reading. And that will be like having 1 point. And it's very hard to draw a line when you only have 1 point. So you just have to add another sentence that would say, I'm going to add more liquid to change the height and take another pressure reading. And I would repeat this for multiple heights of liquid. So in A, we say, firstly, what I need to measure, pressure and height, and secondly, how I would measure it by measuring the height, measuring the pressure, and then doing multiple measurements. The best way to get an A on a test is with a practice test. On my site, I have a free fluids practice test. Click the link below to get it today. In B, now it's going to ask us to talk about analyzing the data and says, what would we plot to make a linear graph that would help us to calculate rho? And I've already told you the answer. So for B1, we'd say that we would put pressure on the vertical axis and height on the horizontal axis. And that's all you need to say. That's correct. So we'll put those things on the axis. And B2 says, what's the relationship between this graph and rho? And here I've already identified that rho g is the slope there. So I would write the slope of this graph equals rho g. And that's what we need to do. So the first two parts really are about thinking about the correct formula and designing an experiment and how you would use that experiment to analyze data. Now, in this question, they have a second part with a different experiment, and we're actually going to analyze data, not talk about how we would analyze data in that part. Here you can see a new picture, which is a new experiment. So there's a tank of water, and there's a hole poked in one side, and the water shooting out with a certain velocity. What's going to happen in this experiment is that students are going to plug that hole and poke another hole, and more water is going to come out. So they're changing the different heights, and each time they change the height, the water is going to flow out. And they've actually already provided us with two things. They have a whole table of data. So the students have done all these measurements, and we can see the data there. Further, they already provide us with a formula. And this is the formula that we're going to use as a basis for plotting and graphing the data. So the question says we need to do a few things with this data. Firstly, we need to label the right axes on the graph, and then we need to take the data and plot the points. And after that, we're going to have to draw a line of best fit, and then use the line of best fit to calculate g, the gravity. So the key thing we have to understand for this is linearization. The function as it is given to us is not a linear function. This graph has a curve on it. If I graph the velocity as a function of h, it's going to go curvy-like. So you may have not studied that in math, you may have. But the idea is we want to massage this to make it linear. What I'm going to do is I'm going to square both sides. So if I square the function, it's v squared equals 2gh. And I'm not going to plot velocity, but velocity squared on that axis against h. And this graph is going to be linear. Beautiful. So the first thing we have to do is say we would label the axes v squared and h, and the units are going to be m squared over s squared, and h is going to be meters. That's it. Now the next part is they ask us to take the data and plot it. But before we do that, we need to take all the velocities and square them, because we want to plot h versus v squared. So here's the table of data. I've copied it down. And I just need to take each of the v numbers and put them into a calculator and square them. Ba-ba! That's all. So I just took v, 2.2 squared is 4.48, 2 squared is 4, and so on. And now I'm going to have to create a graph. So we're going to draw a graph, and you want to think about what numbers you're going to label on the two axes. So I've got my graph, and I've got v squared here and h here. So I need to begin by putting some numbers or scales on there. So when I'm thinking about the scale, I always just like to think about the largest one. So for h, that's 0.25. And for that one, I would say, well, if I had 5 hashes, that would fit quite well in 0.25. So maybe if it's 6, it'll be 0.3 or 5.25. And each one will be 0.5 across. Here, the largest one is 4.84 for v squared. So maybe I want to go up to 5, and that would fit the data pretty nicely. So the way I've drawn it, this one up here is 5, so 4, 3, 2, 1. That's going to fit the v squared quite nicely. So for h, I want to go up to 0.25. Like that. And if we put these scales in a way that's going to fit the data nicely, it should show the line really well and be very easy to draw. So now I'm going to take the data and plot it. So let's start at the bottom. So the first one is 0.05, 1.12. I just do my best, try and get it right there, and 1.21. I can't get that exactly, but I don't need to be precise with this stuff, just pretty good. So let's just put all the points on there. There you go. Those are my points. So 1, 2, 3, 4, 5. So I need to plot those points, and then I need to draw a line of best fit. So these points are not going to fit exactly on the line, but we should say it's approximately linear. And if you draw a straight line, it should go through the middle of them. Hopefully some are a little bit below, some are a little bit above. So that's great. A line of best fits like that. This is actually imitating what it's like to do real physics experiments. You get data and it's not perfectly on the line, and that's okay. So the last step for this question is to take the line of best fit and connect it to the formula. I always like to compare the formula to the y equals mx plus b. If I look at these, I say that v squared is like my y, h is like my x. So what's left is the slope. The 2g is equivalent to the slope. So there you go. All I need to do is calculate the slope of this line to get a value for g. We're going to call this an experimental value for the acceleration due to gravity. So we'll go ahead and look at my line. So I'm just going to go take this point up here, whatever that is, and I'll go back down to 0, 0, and say rise over run. So my rise is 5.25. It's slightly above 5 there. My run is 0.025. So what's my slope going to be? 5.25 divided by 0.25. I'm going to get a little bigger than 20. So my slope is 20.8. So my value for g is going to be 10.4. Now you may be upset about not getting 9.8 or 10. However, this is pretty good. They say anything under 12 is acceptable for this question. So there you go. In this question, parts A and B were each worth 2. There's 2 parts and you need to put some words about them. Part C is worth 6 marks. So that's everything putting it on the graph. And so we've got to think carefully about just making sure all the scale is right. I put units on there and my data is here and a line of best fit. All that together should be worth about 12 marks. And then calculating a number for G is going to be worth 2 marks.